Done this. I got it. Okay, folks, we're going to go ahead and get started now. Let me introduce you to Larry, and he's going to be talking about the journey to ISC. Thank you.
ICS.
ICS, excuse me.
ISC. Okay. Can everybody hear me? Okay, so hey everybody, I'm Larry. I come from Belgium. Today is my presentation about the journey to ICS, but first a brief disclaimer, satisfy my employer. Therefore, I'm employed in the information security industry, but I'm not authorized to speak on behalf of my employer or clients, so everything I say from a personal point of view. About me, I've been into the security industry for over 5 years. I work for PwC Belgium, and I've been active in industrial security for over 2 years. In addition, I like to travel, food, and beer. I'm not an expert yet, but I'm eager to learn. Special thanks to my mentor, Chris, who's sitting here in front of me, for assisting me during the creation of this talk. So about this presentation. 2 years ago, I got a question from one of my managers if I would be up for this challenge to transfer myself from a normal IT security pen tester more towards industrial security. I knew that the ICS hype was starting to rise up with all the activists and nation states targeting critical control systems. So it was an easy decision for me to make. However, this talk is going to be about the very, very basics, share some experiences that I made during this transition, and I hope that this will be a starting point for other people that want to make the transfer as well, just like I did before. So, where can you find operational technology or OT? Basically, you can find it in many different areas, such as food processing plants, chemical plants, nuclear plants, power grid, oil rigs, and many more. However, all these systems, we think it's normal, we take it for granted that we switch on the light, and there's light, we flip the switch and there's light, but nevertheless there are many systems that control that. So some of these risks that we're talking about can endanger human safety, but also environmental effects, material damage, and of course high impact events. Like a few months ago there was in Turkey a nationwide blackout for a few hours, so that had quite some consequences. In the beginning of my journey I saw a number of characteristics, which I like to call cliches, because if you look at IT systems, you tend to replace them after 2-3 years or maybe 5 years. But within industrial control systems, they're built for decades, 10, 20, even 30 years. And also, when they're running for 24/7, 365 days a year, without hardly any maintenance. Also, the most important thing within these systems is availability. Security, as in information security, it's something extra because the systems need to be running, production has to be live all the time. However, nowadays more and more protocols are migrating to have authentication and security in place, but nevertheless, the legacy systems are still present and they will be present until the next upgrade. Also, at some point, there are operators that actually maintain the grid or maintain the control systems to ensure that everything is running smoothly if there's suddenly a peak or if there's suddenly an attack. But in the end, it's not all about control systems. It's also about all the network components that are in place and all the other applications such as data historians and servers. So here's some vocabulary. I'm going to skip it for now because time is limited. But two of the most common terms that you will see is DCS and SCADA, because everybody loves to say SCADA. It's a misused term because when you go to firms like, yeah, we have SCADA in place, and in the end it's just a small control plant having one DCS or something. When you look at SCADA, we talk about the big things spread across the nation, and in the end, when you look at the term SCADA, Supervisor Control and Data Acquisition, the term supervisory is one of the key words here, because it supervises all the outstations that are in place. While in contrast, DCS systems, or distributed control systems, are a bit smaller, such as a nuclear or a chemical plant, and they're standalone systems. However, the first time I saw a control system was actually in a flight case. So you can call it like an engineer for, you could say it's like a Happy Meal for engineers. You can carry it around, you can play with it. But if you look at the overall architecture, it's a bit bigger than that. It has a number of zones. We can define the business zone, the DMZ, operations, process control, safety, and of course enforcement zone. When you look at the enforcement zone, typical devices that you see are data diodes, industrial switches, industrial firewalls, routers as well, that have specifically been designed for handling those exotic protocols. What is very important and what you hardly see, but they're coming right now, is monitoring, because having up-to-date AVs in place is not always a good idea, because the control systems are running and any glitch can have a serious impact. So when we look at the safety zone, which is the next zone, it's actually one of the most important zones. It's a separate network to ensure human safety, because if something goes wrong, people's lives can be at stake. So we're talking about safety valves and safety PLCs, and what those actually do is monitoring the current values. If there's a sudden peak or if there's a sudden issue with current metering values, they will go into a safe state, which is most of the case a shutdown. Now we arrive more at the control zone, process control zone, where we have three different levels. Namely, the first level is the control network, the PCN, or process control network. Here we typically find all the motors, sensors, actuators, and other physical devices. However, when we look on the right, you're going to see the sensor here, but also you see manual valves. That's in the event something goes wrong with the sensor and the engineers can go to the place itself and close it manually. However, when you close it manually, you need to open it manually again, so it doesn't open on its own. So one level up is actually the control devices. So here we're talking about the PLCs, the RTUs, but also dedicated workstations that can be placed in a remote substation. And those devices actually send commands and retrieve values to those lower level components. If you go one level up, we see typically this is where you're going to do some attacks or where USB sticks get plugged in, because we're talking about the HMI panels, the local control rooms, and also the data historian. The data historian records all the data historian records and collects all process data from in the field and transfers it to a GUI, so you see a nice graphical interface for the operators. So level 3 is more for operation support. Here you can find scheduling resources, but also modeling tools, simulation tools, historian replication, and many more. The two other zones are maybe a bit less important for this talk, but for the overall concept, it's pretty important because we're talking about DMZ, which can contain jump host environments for hopping between different zones, but also the plant network and the enterprise network, depending on which size of organization we're dealing with. So this is the overall picture. One of the most fascinating things I heard during my journey was actually air gaps. Everything is air gapped, like physically or using data diodes. So on the picture you can see using a data diode, and on the other side you can see a physical air gap. However, nowadays you tend to see unidirectional gateways that are actually being bypassed and firewalls being in place ensuring a logical air gap. However, you tend to see, a lot of the times you tend to see any rules in the firewall, so they're actually completely useless in a way, because they allow all traffic. So what languages do these components actually speak? Well, you can divide them into large protocol types, such as raw data protocols and high-level data protocols, while the raw data protocols, such as HART or Modbus, reads data and sends commands to the devices, such as reads measurement data and send commands such as start bumps or stop bumps or whatever. However, most of these protocols don't have security in place. They're being transferred in clear text and have no authentication at all. Nowadays, more and more protocols are having authentication, but it's not being implemented yet because the legacy systems are still in place, and it's very costly to upgrade them. When you look at high-level data protocols, such as OPC, ICCP, and MMS, they provide the bridge between different applications and are often also the connection between the different zones, such as between corporate and plant network, because the office environment tends to need that data for financial processing, for SAP, etc. However, looking at the attack landscape, I assume some of you know Shodan. Shodan has a project, ICS Radar. When I created this presentation, I took a screenshot, and as you can see, it's almost 14,000 interconnected devices that speak Modbus all over the world. Knowing that this protocol has no authentication, is in clear text, everybody can do some damage. However, keep in mind that most of the time, or normally, there's an operator sitting behind the control room and monitors everything. So if you change values, the operator might see it and adjust it. So there's not going to be any issue. Types of attacks. They're pretty much common to normal IT infrastructure as well. However, here we're dealing with insecure protocols, hard-coded credentials, such as vendors that implement hidden accounts or hard-coded accounts that you cannot delete. But also physical insecurities, such as on the picture you can see on the bottom there's a rogue modem in place, and on the right-hand side that was actually during an assignment, you could see the control room. It was secured with badge reader access. However, behind the control room there was a meeting room with a sliding window that wasn't secure with a badge reader access, so you can easily hop in. Some other common weaknesses that you tend to find, because they're running 24/7, are unpatched systems. Typically they deploy the system and leave it there for 10-20 years until the next upgrade. But although also vendors are a bit at stake, because this is from a vendor that has published a patch list online with all the approved patches. An attacker can use it as a toolbox to develop customized payloads for targeting a specific plant or targeting a specific type of system. Also, some people tend to use Post-its as a password safe to put everything, to put their credentials on it. They also tend to change once a year or once a decade, depending on which company you're dealing with. Ineffective physical security might be fun as well. Also, some pictures during an assignment, there was a control room with badge reader access, but it was located at the ground floor and had a window open, so it was perfect entry. Also, broken dome cameras and emergency exit doors that you cannot close. I tried closing them from inside, it didn't work, so you can just pry them open and voila, you're inside. Things you might see in IT environments are row access points, unnecessary software. The picture on the left-hand side is from control room as well. They had Power DVD installed. I don't know when operators need to build DVDs, but tends to happen apparently. And also diesel generators that can act as a storage facility for putting your network device boxes and lawnmowers and other stuff that was there. So how can you actually assess those systems and how can you protect yourself against it? Well, preferably test during the factory acceptance or site acceptance testing, because things will break. If you want to use scanners, things will definitely break. Know what you're doing. Don't use point and click, but do some passive traffic sniffing across the different levels, across the architecture. And of course, one of the most important parts is communication. A lot of people don't communicate enough with the operators, and it's actually more beneficial when you talk to them because they can let you know when things are going wrong. So in the end, we have to do, like many organizations, implement defense in depth to ensure the safety of our control systems. So we have to ensure that the system is secure by hardening the system, ensuring that it's up to date, ensuring that the network is secure enough by implementing firewalls, IPSs, IDSs, and etc. And of course, physical security. Ensuring that the policies that are in place also apply to control systems, because most of the time IT is responsible for the devices that are located in the control rooms, but they're unaware of it. So building a team is a first step that you can do. Ensure that operations, security, maintenance, and IT work together and communicate together to ensure a good security team. So once you establish that, you can get some insight on the current situation on how mature your control system is by creating an inventory, determining the different security levels, ensuring that you have policies and procedures in place. If you're in certain countries that require regulatory compliance, ensure that you're compliant to those, and talk to people while creating awareness. You can do that by exercises, tabletop exercises, or USB dropping, or whatever. However, things will take time, because management will be involved, the union might be involved. It's not always that easy to make quick changes. It's almost impossible to make quick changes. So when you're dealing with architecture changes, you need to ensure that the asset owner, system integrator, and the vendor all work together to have a common understanding of what you want to do, and work together by communicating with each other for a decent architecture. Some common pitfalls that I've experienced during my brief years within the industry is that compliance and effectiveness, they collide. They don't really work well together. Nor is a non-flexible approach or throwing money at the problem. Installing firewalls is a good thing, but not configuring them is another. And of course, lack of communication is most of the time the biggest issue. Because if operators don't talk to management, or management doesn't say anything to operators, you don't know about each other, and you don't know the issues on how you can further collaborate. Finally, some standards. There's a link to the ICS cert page, which is going to be filled with many other regulations that you can use. So if you have any questions, feel free to ask. Okay, thanks.